Step number 1. If it was not frozen, you could actually see step number 1. Multiply the coefficients. Multiply the coefficients. Step number 2. If the variables are the same, add their exponents. If the variables are the same, add their exponents. So an example, x times x, you should have looked at yesterday. If you have an x bar times an x bar, what shape does it form? Square, and that's because this is x to the 1, and this is x to the 1, and when we add 1 plus 1, we get x. 1 plus 1? 2. That's y equals an x squared because you're adding the exponents. If we had y squared times y cubed, for example, something you can't even do with tiles because we don't have three-dimensional tiles, this would be y to the 5. Okay, that's the trick with multiplying variables. You add the exponents. Times x times x. David, where's your note package? Sorry? We've been working on this package for a week and a half now. Okay, so where do I keep extra copies? Yeah, so go get one. Step number 3, if the variables are different, smoosh them together. It's a very technical math term. Smoosh them together. Yeah, just smush them. Put it together. Put them together. An example, x times y. We just smush that. That becomes xy. A squared times b. Smush it together, it becomes a squared b. Okay, so if the variables are the same, we add the exponents. If they're different, we just write them together. So example number 1, we're just going to start with monomials, so just little guys, and then we'll eventually get into the polynomials. So coefficient times coefficient. If the variables are the same, we add the exponents. Variables are different, we just write them all together. So 3 times x. Well, this is actually 3 times imaginary 1 in front of the x. So what's 3 times 1? 3x. X, exactly. 3 times x, 3x. We just smush it together. 2 times 5x. Well, what's 2 times 5? And then we just smush the x. X, 10x. 8 times, ooh, negative. What's this negative hanging around here? Well, that's just a negative 1. So what's 8 times negative 1? Negative 8. And then what are we going to smush behind it? X. 2x times x. So that's 2 times imaginary 1 is 2. If the variables are the same, what do we do with the exponents? Add them. So we have an x to the 1 and an x to the 1, and an x to the 1 times x to the 1 is an x to the 2, 2x squared. Coefficient times coefficient, so negative 4 times 3 is negative 12. Are the variables the same? Nope, smush it all together, negative 12, xy. Coefficient times coefficient, so negative 2 times 3, negative 6. X times x is x squared. Are you starting to see the patterns? Ooh, crazy one here. There's a k, there's a c, there's negatives in here. Coefficient times coefficient, so negative 4 times negative 3, 12. Are the variables the same? No, so what do we do with them? Smush them together, k, c. Ooh, negative 3, some crazy talk going on here. Well, this is just like negatives from before. So a negative 1 times negative 3, negative equals positive 3. And what do I do with the x? Just smush it together, 3x. The last one for example 1, 2 times negative 3, negative 6. Are the variables the same? Smush them together, I get negative 6, BC. Show me your thumb so far in example 1. I'm getting it, I'm not getting it, I'm kind of getting it. Okay. To multiply polynomials, we use the distributive property. Sounds so fancy. The distributive property. Grabbing my red pen. So I'm going to first give you the distributive property in math, which to the right brains probably won't be much, and then I'll give it to you in words. So the distributive property says that A times bracket B plus C equals, we do A times B, which is AB, and we do A times C, which is AC. That's distributive property. What we've done is given the A to B and the A to C. We distributed the A. Not like anything at the beginning, but once you get to learn it. It's called distributive property. What we've done with the A is given it to everything in brackets. So multiply each term in brackets by the term outside the brackets. Multiply each term in brackets by the term outside the brackets. In brackets by the term outside the brackets. If that still doesn't make sense, let's look at example number 2, because it might make more sense with an example. Distribution or distributive property says I have to take this 2 and I have to multiply it by the x, and I have to multiply it by the 5. That's a distribution property. I have to give the 2 to everything. So I'm going to write out the long way for the first couple, but we typically don't write this out in every question. But what we're doing is 2 times x, and then we're doing 2 times 5. Okay, so what I've done is given the 2 to the x and given the 2 to the 5. And this becomes just like example number 1. What's 2 times x? 2x. What's 2 times 5? Answer is 2x plus 10. That's called distribution or distributive property. You have to give the number on the outside to everything inside the brackets. What does this picture have to do with distribution? So it's Halloween, kids come to your door, ding dong, there's 3 of them standing there. Do you give candy to just the first kid? Yeah, because what's going to happen with the other 2 if you do that? They're going to cry. So at Halloween, you have to give candy to everyone. That's distribution. So the 2 is like you handing out the candy. The x and the 5 are like the kids. You have to give to the x and give to the 5. So candy goes in the first bag, goes in the second bag, goes in the third bag, then you probably eat one yourself. Okay? That's distribution. Everybody gets whatever you're giving out. Let's look at crazy number 3. Negative 3 on the outside, trinomial on the inside. All it means is distribution is you have to multiply the negative 3 by the x squared, the negative 3 by the negative 3x, and the negative 3 by the 4. So it's like 3 little questions in one. Sorry? Again, I'm going to write it out the long way for the first couple, but typically we don't write out this step, but if your brain needs it, it's fine. We're going to do negative 3 times x squared. Then we're going to do negative 3 times negative 3x. Then we're going to do negative 3 times 4. So what I've done is I've distributed that negative 3. I gave it to everybody in the brackets. Negative 3 times x squared. Smush it together. Negative 3x squared. Second term, I've got a coefficient times coefficient, so negative 3 times negative 3. Positive 9. What do I do with the x that's hanging out there? Just smush them with the 9, 9x. The last term, I've got a negative 3 times 4. That's just a number times a number, which gives me negative 12. For some visual people and right brain people, if you have trouble seeing, try just circling the terms, because sometimes it's a little bit easier to see what we're multiplying there. Kayla, I don't have my phone out right now. Number 4, how do you know when you're doing distribution? So what's in this example, and example 2 and example 3 that wasn't so much in example 1? Yeah, this is more than a monomial. So this will be a binomial, a trinomial, a polynomial. It's when you have 2 terms in the brackets. It means we give the negative 4 to the 2 and the negative 4 to the negative m. Again, for the first couple, I'm going to write it out in steps, but I'm going to drop this in a couple examples. So I'm going to give the negative 4 to the 2, and then I'm going to give the negative 4 to the negative m. Negative 4 times 2?
8.
Kind of? Yep. Negative 4 times negative m, well, what's negative 4 times negative 1? Plus 4, and what do I do with the m? Smush it together, 4m. Show me your thumb. I'm getting this, I'm kind of getting this, I'm not. You have to put it really high. I can't see if it's in front of you. Good. Okay, let's do this one. Negative 5m is going to go to 4n. Negative 5m is going to go to 5m, or 3m, sorry. Again, if your brain wants to write this out as 2 separate questions, sometimes putting a gap helps your brain seem to, or to see as well what's going on. So you can always write it as 2 different questions and put a space in between. Coefficient times coefficient, so minus 5 times 4. Perfect. Do m and n have the same variable? Nope. So what do we do when they're different variables? Smush it, mn. No, other people are just quiet. The second term, I have negative 5 times 3, negative 15. Are the variables the same? Okay, so I've got an m to the 1 and an m to the 1, and m times m makes m squared. Turn and talk for number 6. So just turn to someone in front, behind, beside you. Try the question together. I'm going to show the right brains a different way to do these kinds of questions. It'll work for some of you, it won't work for others, and that's fine. If it doesn't work, then just ignore it. I'm going to do it up top so I have room in the bottom. I'm going to put 3 vertical lines. And at the top of them, I'm going to write the 3 terms that are in brackets, so 2ab, 4b, negative 2a. So I'm just splitting up that trinomial. And then on the left-hand side, I'm going to write the monomial that's on the outside, so my negative ab. Going to drop my pen on the floor. Then I'm going to pick it up. And so then what you can do is just multiply the intersection. So these 2 are going to multiply together, and I'm going to put the answer in this box. So negative 1 times 2, kind of, negative 2. A times a squared. B times b, b squared. Negative ab times 4b, so again, I'm just multiplying the intersection of them. So negative a times 4, negative 4. A times no other A, so he's just going to stay. B times B, B squared. Negative times negative 2, positive 2. A times A squared. What do I do with this B that's just kind of hanging around? Smush them on the end. Okay. If you like that kind of chart idea, you could use that as well. If that doesn't work for you, you can use the arrows, you can multiply out the terms, you can do it whatever way you need to do it. Either way in the end should all be the same. You should have negative 2a squared b squared, followed by negative 4ab squared, followed by plus 2ab squared. Turn and talk to someone different. So somebody you just didn't talk to. Try this one together. We have to do 4x times x squared, 4x times negative 5x, and 4x times negative 3. If you like the table, use the table. If you like to write it out, whatever way you want to do it. 4x times x squared. Well, 4 times 1 is x times an x squared, x cubed, x to the 3. Where did the cube come from? Because there's 1 on the first x and 2 on the second x, and when we multiply the same variable, we add the exponents. Second term, 4 times negative 5, negative 20, x times x, x squared. The last term, I have 4 times negative 3, and then I have an x that's just hanging around, so the x just hangs around there. Who got it? 4x cubed minus 20x squared minus 12x. High five to you guys. Give me a thumb again. How are we doing so far? I'm getting it, kind of getting it, not getting it. Good, good. Some of you have moved up. That's awesome. What do you do with 8 when there's 2 sets of brackets? Well, all I'm going to do is just put an imaginary little dividing line in between them. Let's just look at the first one first. So ignore everything after that division line. What do I need to distribute? The 2. So the 2 is going to go to the p, and the 2 is going to go to the negative 3. 2 times p. 2 times 3, 6. Now I'm going to ignore that left-hand side, and I'm just going to look at the right-hand side. What do I need to distribute? The minus 6. Minus 6 needs to go to the p, and minus 6 needs to go to minus 5. Minus 6 times p. It's always funny when you use the variable p. Negative 6 times negative 5. Now what I'm going to do is just smush those all together. So I have a 2p plus 6, a minus 6p plus 30. And this becomes a question from last week where we're just simplifying the like terms. So what's the same term as a 2p? 6p. Negative 6p. Okay, let's add those together. If you have 2 of something and you take away 6 of the same somethings, how many somethings are left? Negative 4p. Then I have a 6 and a plus 30, and if I smush those together, we get plus 36. There's your final answer. So when you have 2 brackets in the question, you just do them separately and then just collect your like terms. 1 to go, then some time to work. Here's an application question. So application questions are where it doesn't specifically say you need to multiply. You need to apply your knowledge to a question. Read to read. Okay, read to understand. Key word is area. How do you find area of a rectangle? Length times width. Excuse me, what's the length of this rectangle? What's the width of this rectangle? Now all I'm going to do is I'm going to move that 4x, and instead of being behind the brackets, where am I going to put them? In front of the brackets, because that's the way we're used to seeing them in all the above examples. So I'm just going to take 4x and move them in front. Why can I do that mathematically? So why can I just switch the order like that? Because it's multiplying. So what's 2 times 3? 6. And what's 3 times 2? 6. Does it matter the order we do them? The reason we like it in front is because it's the way we're used to seeing the distribution, so I need to give that 4x to everybody. A 4x times a 3x, 4 times 3 is? 4 times 3 is? 12. X times x is? X squared. I said squared, then wrote 6. There we go, x squared. The second term of 4x times a 6, well, 4 times 6 is? And the x that's hanging around? Smush it on. There's the area of the rectangle.